Hello and welcome to The Road to Autonomy. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. Hello and welcome to The Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to welcome Jan Becker, CEO and co-founder of Apex AI. Jan, welcome to the podcast.
Hey, Grayson. Thanks for having me on the podcast.
I'm excited to have you here, Jan, because you have an extremely long history in autonomy. You've seen a lot, you've done a lot, and I'm really excited for your perspective here. And I want to go in the way back autonomy here, back to 2007. In 2007, you were part of the Stanford team that won second place at the 2007 DARPA Urban Challenge. What was that experience like? The technology wasn't nearly advanced in 2007 as it is today.
No, it wasn't, but it was really, both the Grant and the Urban Challenge combined were really, people call it the Woodstock of robotics, and a phenomenal group of people. So in total, about 100 teams for each event got together and in a very intense 1 year worked on advancing a topic. And in hindsight, really from research, I've been working on autonomous driving since 97, where back then we always said, it's at least 20 years out to even remotely be able to put autonomous driving into something like a product. And then all of a sudden, the Grant and Urban Challenges were able to show that, yes, autonomous driving can be done, that we can actually move from an R&D stage into a product development stage. And then Waymo afterwards spun out of the Stanford and the Carnegie Mellon team, and then they took it to a whole next level. And that sparked the whole autonomous driving industry as we have it today.
What sparked you to start working on autonomy in 97? Late 90s, we had Nirvana. We had really great bands in the late 90s, and that was really cool, the grunge movement in Seattle. But you said, no, I'm going to work on autonomous driving. I'm not going to go listen to all this great music. What sparked that?
So I went to school both in Germany and in the US, and then was looking for a PhD position in 97 worldwide. And then I came across a project in northern Germany where the University of Braunschweig, where I then did my PhD at, collaborated with Volkswagen Research to automate their endurance testing. So Volkswagen and probably most car makers run vehicles on a special test track. They call it the hardened course. In the Volkswagen case, 24/7 for about a month, driving about 10,000 miles, which is then equivalent to 140,000 miles in real traffic. So about 14 times the stress of regular road driving. So they go through the mechanical lifetime of a vehicle in about a month. So it's very stressful for the cars, but equally stressful for the test drivers. So the idea was to automate that. The key challenge back then was actually that cars didn't have the actuators you have today. So today you interface via the CAN bus with the steering for parking automation, or the powertrain and the braking system, where interfaces exist for a long time for instance, adaptive cruise control. None of that existed in 97. So we actually first had to build an almost humanoid robot with 3 legs for the pedals, an arm for the gear shifter, an arm for the steering wheel to drive the car. And we worked with pre-production cameras, pre-production radar, because ACC at the time wasn't even launched as a product. We worked with industrial LiDAR for perception. We built our own RTK GPS system because the one we wanted wasn't commercially available. So we really built almost everything from scratch. It actually ended up working beautifully. So we were able to drive fully autonomously without a driver on test tracks, but it ended up being much more expensive than what the car company, in this case Volkswagen, wanted to spend to put the testing automation into production.
It always comes down to what is the potential profit, what is the revenue could be generated from this. I'm really curious. You build a robot to drive a car. There's that great children's book, If I Built a Car, and there's a robot that pops up to drive the children, and the children, I want an ice cream parlor, I want a swimming pool, but it's driven and by a robot. And I think about a robot, especially in 97, the limitations. If a robot wants to make a wide left turn or a wide right turn, how did you design the hand so the robot didn't freeze it? There's no more room to turn. How did you design that?
So it was actually an electric actuator which was attached to the steering wheel, such that the center axis of the actuator was aligned to the center axis of the steering wheel. So we could make arbitrary amount of turns much, much faster than any human could do.
Okay, so you're innovating since '97 on autonomy. You're a member of the 2007 Stanford team at the DARPA Urban Challenge. 2007, 15 years ago. A lot has changed from then. The components are better. We have electronics in cars. How would you describe the changing landscape of autonomy from 2007 to today?
Yeah, so as I mentioned before, one of the outcomes of the DARPA Urban Challenge was that Google started and funded Waymo, and Waymo then really showed in my opinion, showed the automotive companies that autonomous driving can be done as a product. Because up to then, OEMs, tier one suppliers were really saying, yeah, we don't really need to work on autonomous driving. Our customers, yes, they want safety systems and they want better, advanced driver assistance, but autonomous driving is really not for us. And then Waymo came and showed, yeah, it can be done. And then that mindset changed over the next probably 5 to 8 years until around 2015-ish, when in between we had this really revolution in terms of capabilities, which was sparked by progress in machine learning and deep learning. And all of a sudden, also the vision of autonomous driving actually became reality. We could all of a sudden, through enhanced computer vision, understand, not just see objects, but really understand complete street scenes, which is then the enabler for making wise and meaningful decisions. And that then around 2015 led to all of a sudden a significant amount of venture funding go into autonomous driving. And then we, yes, also saw a number of startups probably over promising and ending up under delivering a bit. So in 2015, I remember a number of companies essentially promising a fleet of 1 million robot taxis within 5 years. And now the 5 years are up. And yes, if I'm in the middle of Silicon Valley in Palo Alto, but there isn't 1 million robot taxis driving, even though there are actually a couple of hundred, but there aren't 1 million robot taxis driving here on Charleston Street in front of my office.
We're getting there. Your office, you're in the Fairchild Wheeler office. That was last home to Voyage, which is now a part of Cruise. And if you look at what Cruise is doing, they're operating fully driverless in 3 states. Waymo's doing it in 2 states. The technology is beginning to scale. I want to add some financial aspect to this. And since 2015, 7.5 billion a year on average has been invested into autonomous driving technologies globally. There's an interesting trend that's starting to emerge, and I would say it's dividing the industry. The days of the timeline are gone. Nobody's talking about the timeline. We shot ourselves in the foot, if you want to say we shot ourselves in the head. But now the big debate is personally owned AVs versus fleet AVs. Miss Mary Barra at GM, she's publicly stated that that's something they're looking into. Several of the larger OEMs have said that's something that they're looking to. Won't give a timeline. We've learned that lesson, but it's something they're looking into. What do you think about personally owned autonomous vehicles? Are they going to come at some point in the future? And if so, will it be driven by consumer demand, where the consumers say, the robotaxi is great if I want to go out to dinner because I don't have the liability if I drink. But if I want to take the family to, say, Disneyland, so you're in the Bay Area and you want to drive down Disneyland in Anaheim, perhaps you want to use your personally owned AV for that. How do you see that market evolving, if there is a market there at all?
I think there isn't an immediate market. I think it's still also from a technology perspective, a long way out to, if you look at it from a consumer perspective, if I make a significant investment in buying a vehicle, I want to take the vehicle wherever I want to go. And that ability, providing AVs with that ability is more than 5 or 10 years out. That's probably more the 20, 30 year horizon, which is a long, long time. So I think there will still be this dual existence of personally owned vehicles that with increasing amounts of driver assistance and safety systems. If you look at the vehicles that Mercedes launched recently, which was the first manufacturer that received, both in Europe and in some states here in the US, approval for a level 3 system. So there are advances being made there. And those are great as a personally owned vehicle because I can drive them wherever I want to drive them. And then when I want to, on certain roads where a level 3 driving is feasible, I can then activate the level 3 system. But other than that, if I need a taxi. Taxi is all only operate in geographically confined areas. I think it'll be the same for robotaxis. But another interesting use case of having automation for fleets is actually the commercial vehicle space.
Yeah. Commercial vehicles, interesting. I want to get that for a minute. Mercedes Level 2 system today is very good. I own one. It works very well on the highway. I took it from my house on the highway to Disney World. We're Disney World on the East Coast and you're Disneyland on the West Coast. And it was phenomenal. I said to my wife, she's like, what was the best part? I said, I arrived at Disney World and I was relaxed. I wasn't stressed out. On the level 3 system, do you see a point where, let's say, for instance, an individual lives in a suburban area, not a lot of traffic. I'm just going to use broad terms. You say 4 to 5 miles away from the highway. Pretty simple. Go out of the driveway, take a right, take a left. You're on the highway. And then when they get to the complex section of Disney World, you have to take over manually. But do you see perhaps that first part of the journey being able to go fully autonomous until you hit the congestion, which is Disney World?
So for the foreseeable future, I see level 3 being activatable on highways, freeways, where you have a confined environment with limited complexity. And I expect that humans will still need to drive the first couple of miles to the highway.
Yeah. And that ties right into commercial vehicle, because you're seeing the trend, especially in the autonomous trucking side of the industry. You're seeing this growing trend of depots. And I spoke to the good folks at Prologis, and they said, we're going to build a depot in a box. And I said, well, how big is the business? They said, by 2030, we view it as $1 billion a year business. We're going to build the depot half a mile off the highway, right adjacent to the highway where the land is. The autonomous truck will pull in, and then it'll switch to a human-driven truck. That's an interesting business that creates a whole bunch of side businesses there. And it's starting to scale. You're seeing Kodiak doing it very well. You're seeing Waymo testing. You're seeing Torque doing it well. Is that how you see commercial rolling out from, say, depot to depot, where it's operating fully autonomously on the highway, gets to a depot, and then goes into a human-driven vehicle? Or I'll give a shout-out to the good friends at Gatik, perhaps going from there from a short haul in a Gatik vehicle.
Yeah, exactly. So you have the hub-to-hub use case. Then you have the middle mile use case from the hub to the local depot, and then you have the last mile. And those are 3 different use cases. The low-hanging fruit, in my opinion, is really to automate the hub-to-hub transportation. There are a couple of years, I saw a number that were already 30,000 truck drivers missing in the US. I think by 2030, it's predicted to be 80,000 truck drivers missing. So addressing the low-hanging fruits first, automating the long driving on highways where there's limited complexity is, in my opinion, the lowest hanging fruit, which now, as you pointed out, a number of companies are addressing successfully.
And the highway, if you're a consumer, we have inflation pegged at 8.9%. Consumer sentiment still holds on, even though it dipped a little today. You can technically lower the cost of goods if you remove the driver. That is a very positive economic benefit, and perhaps it could even potentially lower inflation. When do we get to a point where individuals are looking at autonomy from the positive economic benefits that we'll have? It's not the here's Jan. I've been working on this since '97. When did the economists come and say, "Wait a second, this has a very positive economic benefit on the economy"?
I think that's actually a topic and a task for all of us, where hopefully also your podcast is contributing to getting the message out that there are positive sides of autonomy. In the past, I've seen, my opinion, too many reports of what are the dangers, what are the risks, what are the both economic risks, but also a risk in terms of safety of autonomous vehicles. And I actually must say that both the big companies and the startups in the space like Cruise and Waymo have done a really good job getting the message out how they deal with safety in a reliable and sustainable way.
What Cruise and Waymo have done, one of the most important things they've done that, in my opinion, they don't get enough credit for, they've helped to develop public trust with autonomous vehicles. When they're operating in the dense urban environments of Phoenix, Austin, or San Francisco, they're putting passengers in those vehicles. They're building trust. And Waymo did one of the most brilliant things that is not talked a lot about anymore, and you remember this. They put the blind gentleman in Austin in the Firefly vehicle and drove around Austin and made that incredible, heartwarming video. That was a big breakthrough movement. Why do they not get enough credit for developing this trust with the vehicle? Because if you're a consumer, you're used to, I got to have a human. But yet here we go. The public is trusting the Waymo driver to drive them.
Hmm. And I think we are slowly and steadily over time are getting there. And you go to San Francisco, and there are on certain streets there's either a Waymo or a cruise vehicle driving by at certain times of the day, almost every minute. Over time, consumers think it's normal to have driverless vehicles on the road, and I think in San Francisco we actually went a long way already.
We've gone a long way. In my opinion, you're the founder of Apex AI. You're merely in the first inning of where you're trying to go. We talked about the industry. The industry's evolved and the industry is maturing. It's getting scalable, and I'm going to continue to shine a light on the positive economics of it. We haven't touched on where do you see Apex AI playing in this vast ecosystem of autonomy?
Hmm. So what we've seen, to give you the background, what we've seen over probably the last 10-ish years is a number of companies developing a vertical stack. So developing for one specific use case, all components in-house that are required to address that use case. Turns out that that is a much larger task as a whole than many of those companies thought. So what we are providing to address that are two components, which are so-called horizontal layers. So addressing two specific aspects in such a broad and generically applicable way that it is not addressing just autonomous driving, but also driver assistance, infotainment, telematics, powertrain software, and so on. So those two layers are specifically an SDK, which you can look at in the same way as the SDK for an Android phone or an iPhone exists. So Android and iPhone software is developed by building on top of the Android SDK or the iOS SDK, which is essentially a piece of software you download from Apple or from Google, which contains pre-built libraries, which then contain all the functions that are common to many apps. How do you open a virtual keyboard? How do you access a speaker? How do you open an app in the first place? How do you close an app? How do you download data from the internet and so on? So all the kind of common functionality is included there. We have developed such an SDK for mobility applications. So it contains predefined libraries that enable you to start processes, to build processes that process sensor data, for instance, deterministically, so that they run at exactly the same execution every time you run them, which is a requirement for real-time software and for safe and reliable software. So we take out in a nutshell, we take out the challenges that relate to building safe software, building reliable software, building software in real time, so that the application developers can focus on what they can do best, which is building a certain application, building an infotainment system, building a perception system.
Are there limitations to what your customers will be able to build on top of your platform?
Within the limitation of mobility, no, not really. So we have customers building driver assistance systems. We have customers building full level 4 stacks. We have customers that build telematics units in cabin monitoring, powertrain, and not just limited to automotive. We also have applications in robotics, in avionics, in marine. So it's really any mobility application that requires either performance or real time or safety or security guarantees.
Why would an individual, let's call this individual a developer, why would they choose the Apex platform over traditional ROS or another platform?
So when that actually goes back to the origin of the company. So before I started Apex AI in 2017, both my co-founder and I have been involved with the ROS project for almost 10 years, for 8-9 years. And ROS, that was really my lesson learned, my experience. ROS is great to enable rapid prototyping because again, it provides all the functionality that is common to many robotic applications, but where then a lot of companies, really all companies I've observed, fail is taking a ROS build application from the prototype stage to a product stage. ROS is not real time, ROS is not reliable. And most importantly, ROS is not safety certified for mobility applications. And this is exactly what we've added to ROS. So when we started the company in late 2017, ROS 2 had just come out, and we back then forked ROS 2 and then fundamentally rebuilt the software underneath using the same architecture and the same APIs, but we rewrote it such that, again, it's real time, it's reliable, and we were then able to safety certify it in 2021. So what that provides is now an easy migration path from your ROS-based prototype to a ROS-based product. Mm-hmm. So there are a number of independent assessors that provide functional safety certification. It's for automotive based on the norm ISO 26262. And yes, we use the TÜV Nord for our certification.
What drove you towards TÜV that you chose them for your certification versus a potential competitor of theirs?
Yeah, so we looked at a number of safety assessors and found that the TÜV, there are three actually in Germany or more. The one we work with was most capable and most proficient in helping us to certify modern C++ code. So opposed to old school automotive software, which is usually written in C, we use ROS is based on, and we use modern C++ to develop our software that allows uh, really through modern language constructs in C++ allows scaling or building scalable software much better. So you can include significantly more functionality in less code. And that makes it easier to test software, to scale software, ultimately also to certify software. And for the most recent language versions of C++, in some instances, the standards don't even exist. So we found that the TÜV for instance, C++ 14 and 17 was most knowledgeable, helping us not just certifying the software, but also really making our software safe and secure.
Do you feel that the TÜV safety certifications helped your business gain market share and scale?
Totally. So when we started the company in 2017, we actually had to overcome and work against the widespread opinion that yes, ROS is great for prototyping, but ROS cannot be made safe, ROS cannot be made secure, and ROS cannot be certified. So really the first goal we set for ourselves is not just to rewrite ROS to make it reliable, but really to go through safety certification to overcome that opinion by showing, yes, it can be made safe and secure and certified. The opinion was actually mostly based on ROS 1, which was the first version of ROS, which came out in 2010. Then there was a re-architecture, which then led to ROS 2 starting around 2015. And ROS 2 then came out late 2017, which coincided with when we started the company, Apex AI. But really that opinion, ROS cannot be made safe and secure and certified, is mostly based on ROS 1 on the first iteration. And a lot of the challenges in terms of the architecture were actually overcome with ROS 2. So we found with ROS 2 a really solid foundation to work with, which we also helped shape before we started Apex AI. And that's what then we were based on. So we based on ROS 2, forked it, certified it.
Outside of safety, how is Apex increasing the security? Because when I think about security for the vehicle, there's a lot of concern in the media. Oh, the vehicle could get hacked. I think Howard Marks has this great saying: second level thinking. What's next? And I think about the vehicles are going to become giant credit card process. They're going to become giant commerce. Can Apex, if you give, say, Visa, MasterCard, Discover, Amex a quote unquote pipe, can you meet all the PCI compliance from a security standpoint? So the passenger vehicle says, okay, vehicle, purchase Starbucks coffee. Okay, vehicle, buy this experience, that it can be a safe and secure experience that you can limit fraud?
Yeah, we are working on that as we speak. It's obviously not done yet, but yes, I think we can. So if you look at a vehicle you bought even today or a couple of years ago, communication in the vehicle is mostly based on the CAN bus. CAN bus is a very simple bus system, basically consisting of two wires, where very small messages are sent across the bus with very high reliability. So it doesn't work for camera data or for LiDAR data, but it is a very reliable system. We've actually more recently seen more and more an increasing number of attacks where persons have knowledge of where the wires are running in the vehicle, and then they drill holes or rip parts of the body open to access those wires, and then interject messages to open the vehicle or to even start the vehicle. And the reason that works is because there is little to no authentication, encryption, and security on the CAN bus. So more modern vehicles use more modern bus systems. And we are actually currently working on our second product, which is called Apex IDA, which is a communication system to address all communication needs across different components in the vehicle through a number of different protocols. So, for instance, one of the more modern protocols, which is used in robotics and also in ROS, is called DDS, Data Distribution Services. So, on top of DDS, we then build security measures such as authentication and encryption, where authentication essentially enables that participants can only communicate with each other once they've authenticated each other with a certain authentication token. Or encryption then also encrypts the messages on the bus such that others cannot neither read nor send messages unless they participate in the encryption pattern. Those and more are measures we are taking to make vehicle communication both within the vehicle, but also vehicle to cloud, which could then be used for the use case you just described to make that safe and secure.
This might sound like a layman question, but you open Pandora's box and I'm going into it. Is encryption not standard on vehicles today?
No, on the CAN bus, encryption is not standard, no.
Why? You don't even have, you just open the Financial Times, the Wall Street Journal. It doesn't take a rocket scientist to figure out that there's a hacker out there or an individual who's trying to figure out to get out of jail, and they keep putting him in worse and worse jails and he keeps escaping. Or you just see what's happening in San Francisco. How is that not talked about? Because you would think that, holy cow, and I sound like Phil Rizzuto in that comment there, the late Yankees broadcaster. Where's this conversation? This seems that this is a very important conversation that has to take place today.
One of the root causes here is that just innovation takes a long time from idea to development to product to making it into the vehicle. So taking CAN bus as an example, was invented in the late 80s, early 90s, and then put into cars probably in the second half of the 90s. And it just takes time for an established product to get replaced by a better one. And now that's exactly what's happening. The DDS, some IP are protocols that are making it into cars. Then only more recently, cars became connected to the cloud. So you now have this additional access layer, which provides both services, but also risk and an additional entry door into the car, which is both the cell phone connection, the Bluetooth. You want to connect your Bluetooth to the car to play music, or you want to use a Wi-Fi hotspot in the car for connectivity. But those are typically running consumer electronic software, which is not safe per se. So you now need to add additional onion layers in terms of firewall, encryption, authentication, and so on to actually use the technology that is yet convenient to use, but then in the case of a vehicle, in a safe and reliable and secure way.
Over-the-air updates are popular. My vehicle had an update the other day, and a new feature for the map. Are over-the-air updates encrypted by default?
Yes, they should be. So, well, the way that would work is, and there are companies that have been doing it successfully, also in vehicles for many, many years, such as Tesla. So it's not rocket science to manage both infotainment software, but also software for ADAS systems and safety relevant software in a vehicle in a safe and reliable way. So yes, that is, some manufacturers have implemented it successfully in a safe way.
As you scale and introduce the Apex IDA, will it be encrypted by default?
So what we provide is essentially a toolbox, and then we leave it and we enable the developer of applications to use encryption and authentication, to use that example in the communication case. But there may be use cases where that's not the best choice. But we give the developer the choice and the toolbox to use it.
That's a very big positive. I repeat, that's a very, very big positive step in the right direction. So, one side of the house of your business, you have the Apex IDA software, and the other side of your house, you have the Apex Grace software. How do they complement each other so your customers can succeed?
Mhm. So Apex Grace is this abstraction layer, this SDK, which abstracts all the complexity of base software, of hardware underneath to the application developer, so that the application developer can really focus on developing the application, not the underlying software. Apex IDA is that communication protocol software that provides also as an SDK, as a library, all the different communication protocols that are needed to communicate with different components. So the cloud, other vehicles, infrastructure, but also other components in the car. For instance, your infotainment system will need to talk to your powertrain or your braking system or your adaptive cruise control, your radar, to keep the distance to the car in front of you. So what enables Apex IDA.
So, I just focus on the communication. You can say Grace is focused on the driving functionalities. We're going to move eventually to higher levels of autonomy. We're going to move to more complex driving environments with autonomy. How will the Apex Grace software scale? Will you push updates there, or how will that scale as the autonomy gets more and more complex?
Mhm. So what we provide are the libraries, the functionality to enable our customers, the developers, the car companies to build software that scales. We do that on the one hand through software that abstracts complexity really, really well. So you can implement complex functions in comparably small amount of code. Then, in addition, as you pointed out, software, just like software on your smartphone, never ends. The development never ends. There are continuous updates to both the base software, which is what we provide, and the application software, which is what our customers provide ultimately to their customers, which are then the end users. So you and I driving the vehicle. So that is enabled by our software, but also by modern architectures in cars. So if you bought a car, I think you have a very recent car. I have a couple of old cars. My cars, I drive a lot of classic cars. They're actually typically not connected. They don't have a cell phone modem. They don't have the ability to update software on the ECUs. If you buy a very new car, and Tesla has that implemented since 2015, 2016, you can the manufacturer can, just like software on your phone, push updates to your car computers, to your ECUs, whenever either there's a malfunction detected, or there's a bug detected, or there's simply a new feature that has come out. So cars will become more and more connected mobile smart devices than just cars.
Absolutely. I want to dive in more and deeper into the Grace software here and ask you a scenario.
Hmm.
On one side, I'm a developer that's developing autonomous truck software. And the other side, I'm a developer driving autonomous driving software for robo taxis in cars. Is that two different STKs from Grace, or how does that work?
No, it's actually one and the same SDK. The base functionality required is really does not differ between those use cases. You need to, in a simple explanation, you need to read in data from sensors. Maybe the LiDAR sensor you're using on your robot truck is slightly different from the LiDAR you're using on a robot taxi, but that doesn't change the format of the data the sensor sends. So we provide functions to read and sensor data. We provide functions such that the developer can develop software that processes the sensor data. We then provide the functionality that these two processes One is a driver that reads in the data. The other one is a function that processes the data, that they can communicate to each other efficiently. And that doesn't change. There is no difference between a robot taxi and a robot truck. Also, the robot taxi and the robot truck will run very, very similar hardware. One may be made using two manufacturers as an example. One may be made by Qualcomm, the other one may be made by NVIDIA. That's another advantage that we provide. We abstract the underlying computing hardware away from the developer, meaning the application the developer develops does not notice anymore which specific hardware manufacturer sits underneath, which also then enables moving from one computer manufacturer to another one later on.
I'm going Howard Marks on you again. We're going to go second level thinking. We're going to dive deeper in this. I'm going headfirst into the universal driver debate. There's some individuals in the industry, and you and I know a lot of them, says no such thing. We're going to develop a stack for that can drive just cars. Then there's the other side. We're going to drive for just trucks. And then there's those in the middle said, no, we can have one driver do both. What are your thoughts on that debate? Because what you're building with Grace, you're giving them the tools to essentially do both. But what are your thoughts on the universal driver?
It goes back to what I mentioned earlier. So I think we can, with the right architecture and with the right components, we can build a stack that is fundamentally universal, but then will need a lot of tuning and a lot of adaptation to account for the respective use case. So in a truck, the sensors may be higher. You may need different sensors, and but that is not just an adaptation that needs to happen between truck and vehicle, but also between driving in the US versus driving in Europe, where the velocities may be higher, or it will need a different sensor set depending on whether you're driving in Phoenix, where the sun shines 350 days a year, or you live in Florida and you will need a different sensor set for driving in Alaska. So I truly believe that the architecture can be made universally applicable. I do believe that the components can be developed such that they are universally applicable, but then you do need a lot of tuning, adaptation, testing to really test and customize for the specific use case.
Different sensor sets. That's a new one I haven't heard. You're right. If you're driving in downtown London, you're going through Kensington. That's a lot of traffic. You have a lot of rain. You could have the famous London fog. If you're in Florida, you got sunshine or Jason Urschwitz from Luminar pointed out to me the love bug problem that you have to solve for that where the LiDAR and the bugs hit it. Different sensor sets. Is that how you see this technology scaling? Or even if you're Alaska, it snows. Maybe you need ground penetrating radar there. Is that going to be the next hurdle to overcome different sensor sets as the companies move from the Sun Belt and the California weather into more complex weather environments and then different driving habits globally?
Of course, you definitely need a sensor set that fits to the use case you're addressing. And it pertains to both the sensor hardware, but also the sensor software. So if you take a camera, for example, you will need to relearn to a certain point what, for instance, lane markings look like or what traffic lights look like. The US has 50 states. I haven't counted, but I assume there are at least 100 different kinds of paints being used for the lane markings. And while they look substantially similar to the human eye, they can look significantly different to a camera, and then even more so depending on the lighting source. Some states or cities use white LED street lights, others use yellow or orange lights. That all has an impact. What we've noticed in the past in some project is just moving from one city to the next. Traffic lights have a different brightness because different cities use different vendors for their traffic lights. So then you need to relearn your camera traffic light detection classifier to account for those differences. Then you have differences in driving behavior. For instance, in Pittsburgh, there's a famous Pittsburgh left, where it's a local habit which isn't written down in any rule book, that the first person in a line of cars going to make a left turn gets to go first because the traffic going straight gets to go. That's a local custom, which if you're new to that city, you have to learn. And you have to then also teach cars driving autonomously in the city to account for that.
You have to learn local cultures. In Boston, you've got the infamous roundabouts. We're going to have to conquer those. It's that there was, before Argo shut down, Brian Selesky said a lot, drive like a local. And that's really where this technology is going to have to be, because you don't want to get the person that's honking their horn behind it, because they're going to go to their city council and complain that technology is horrible. And then you have a political shenanigan on your hands. We can both agree on the industry is a very exciting industry. I always say the future of this industry is bright, and it's really exciting. In your opinion, what is the future of the autonomous vehicle industry?
So I've now been working in the autonomous vehicle industry for 25 years. I'm really happy that we are finally at the point where it's not just 20 years out or 10 years out or 5 years out, but we've now, I think we as a community have now identified use cases, hub to hub, port automation, factory automation, where autonomous vehicles actually make sense. And we as an industry are now working on products where I'm now confident we will see them on the road, also running Apex Grace and Apex IDA within very few years. So I'm really happy that we as an industry have now reached that state. We are actually working on products and we will launch them soon.
We're definitely working on products. The ports are going to be a tremendous opportunity, especially the drayage runs, the 60-mile, 70-mile drayage runs that are consistently happening. And you said this earlier, I want to highlight it. Maritime is going to be an astronomical growth opportunity for autonomy. And Jan, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
I think you made an important point earlier, which is that we as a whole, as the community, still have to work on educating the public that there are a lot of benefits to autonomy. And I hope that our listeners take away that is the case.
I'm pretty sure they'll take away the case that is the case. And then they're also going to take away the economic benefits, because week in and week out, I talk about the economic benefits of autonomy. The future is bright, the future is autonomous, and the future is Apex AI. Jan, thank you so much for coming on the road to autonomy today.
Thanks, Grayson, for having me today.
Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter at Road to Autonomy or email podcast@brulteco.com. The Road to Autonomy is produced by Brulte & Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte & Company. The content discussed on this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.